The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disproved as well. Yep, we're pretty sure about the Big Bang as the concept and how it was monumental in creating our universe. But there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that at this point in time, it's not easy to disprove the theory altogether. In the last decade or so, our only saving grace to study the Big Bang was the Hubble Space Telescope. And now, of course, all bets are on the excellent precision of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest points of contention in astronomical study was the expansion of the universe. If you pick some science textbooks from the early 90s or so, you'd read about how the universe is widening. In other words, the universe is expanding. And that's one little scientific fact that we've held on to. But the real snafu here is that perhaps we don't understand what the expansion of the universe entails. And more importantly, we've got to ask ourselves if the universe is actually expanding. Because spoiler alert, the James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped expanding. And hey, while the world is still intact, you might want to improve your internet experience safe and secure because we certainly have. This is why we're happy to reveal our very own secret to secure browsing and accessing deep content. To make some hefty informative videos, today's video is sponsored by the champion of safe and accessible internet, Atlas VPN, with more than 6 million users worldwide. Atlas is changing the game for everyone. Alright, this service won't be available in space, but Atlas would make your internet experience super secure and quick. Can't watch shows that are locked in your region. Connect to Atlas within a microsecond, voila, you're in. You don't have to be an expert in tech or computers to work this service. It works like a charm for anyone and everyone, that too for just $1.83 per month, plus 3 months extra. So why choose Atlas? Atlas kills malware attacks, keeps your searches secure, unlocks content from all over the world, and offers the best deals in the market. You can get all of this for all of your devices via a single subscription. Grab the big deal because now Atlas VPN Premium is just $1.83 per month, plus 3 months extra. And with a 30-day money-back guarantee, protect your privacy and get many benefits of Atlas VPN for a ridiculously low price. You can take this deal by clicking the link in the video description below. Be quick, as it's a limited-time offer. So while we thank Atlas VPN for sponsoring this video, click the link in the description to avail the limited-time offer. Your internet experience just got a whole lot better. And now, before jumping into the implications of this groundbreaking shift from our universe's trajectory, let's just talk about our understanding of this perplexing phenomenon in the first place. The most common knowledge associated with the Big Bang characterizes it as an explosion. And well, fiction and popular media have put solid imagery to this process as well. Any piece of media would depict the inception of the universe as some sort of a blast that hurled tons of energy and matter just spread in every direction. Scientifically speaking, that sort of visualization isn't correct. Despite the widespread use of the explosion and inflation of the word, the birth of the universe wasn't exactly a blast. And scientists want us to correct our understanding of the universe. In NASA's own words, the universe did not expand into space, as space did not exist before the universe. Instead, it is better to think of the Big Bang as the simultaneous appearance of space everywhere in the universe. Our understanding of the phenomenon also reveals that our universe has lived through a durable cosmic period that was only disrupted by the reionization in space. Before that particular chemical conjecture, our universe was just pitch black dark. The let there be light moment of the universe only occurred 400 million years after the Big Bang. Yep, that's right. You see, the big explosion only created the basic tenets of all living beings and heavy bodies in the universe. For 400 million years, the universe was plunged into darkness because, well, it's simple. There were no stars or galaxies. When that was rectified as clumps of gas turned into stars and galaxies, only then did the universe get out of its cosmic dark ages. So here's a little trivia for you guys. When do you think our solar system came into being if the universe was just darkness and eeriness for 400 million years? Well, our solar system was born 9 billion years after the Big Bang. So yeah, sorry sci-fi movies, there's a huge disconnect between the so-called explosion and scientific theory. And of course, this changes everything. The way things are, our universe still exists as a single inception point. It hasn't moved or expanded ever since the Big Bang. What really happens is that space has been stretching all along, and it carries matter with its trajectory. To put it in clear-cut words, the universe isn't expanding the way we visualize it or even understand it. It is actually the active stretching of space that precedes the expansion of the universe. We know it's a bit complicated to comprehend this, but it's also important to understand the implications of what we're about to tell you. For the purpose of this video, we continue to use the phrase the expansion of the universe to signify the active movement of our space, mainly because even scientists are comfortable using the exact framing to describe the recent discovery made by the James Webb Space Telescope. The fact that the universe has stopped expanding is both terrifying and inconsistent with our previous theoretical knowledge of this baffling phenomenon. So what do we make of it? Let's get right into that. To understand the scope of the implications, we need to go back to our existing studies of the universe. Back when the universe was born, aka during the Big Bang, our universe was smaller than a single atom. Ever since then, the universe has been stretching outward continuously. Initially, it expanded outward at unfathomable speeds. But as the universe grew older, it continued to expand and stretch out more. This is the moment that everyone thought would last forever. After all, if the Big Bang was a beginning of sorts, we should expect a corresponding end. Our theoretical knowledge hence suggests that our universe is set on a singular trajectory of expansion without any plausible probability of a slowdown. In other words, we were sure of the ever-expanding nature of the universe. And that idea would have allowed us to figure out how and when the world would end. The James Webb Space Telescope shatters our preconceived notions of the universe's expansion. First things first, JWS's data reveals that the universe has stopped expanding. The new images that the James Webb Telescope has received suggest that the universe's expansion has considerably slowed down. If anything, the universe may not be expanding at all. How exactly did this discovery come about? Well, with the recent images, scientists have revealed that the light waves have been seemingly bending as they have traveled through space and time. The very bending nature of the light indicates that it is the space that has stopped expanding. The new images reveal something that is far beyond what the Hubble Space Telescope has achieved. Our previous knowledge was based on Hubble studies, and hence it didn't reveal the most important aspect of the universe. The new images have shown that the universe is essentially curved. The mind-boggling discovery, therefore, shows that the universe is a sphere, and our very existence, including space and time, is wrapped inside the sphere. With this, another major breakthrough is the light that has reached the new telescope. The more we look at the images, the more proof we have that the Big Bang theory is both true and outdated. It is true because the universe began at one point and it has been ever expanding. But at the same time, it is outdated because the expansion of the universe has been largely debunked with JWS's new data. If we study the data, we see that the universe, aka the spherical point, has stopped expanding. And that very characteristic of the universe hints at the most plausible fate of the universe's end. As we said, the universe was created with a Big Bang, but we have never stopped to wonder what would be the exact nature of the universe when it ends. Scientists have revealed the possibilities of how the world ends, and spoiler alert, it's going to end the same way it began. The expansion has stopped, and what happens next is that the stretching of space would also slow down. The new data also reveals the plausible end, which is the big crunch. We know it's too much for anyone to wrap their heads around, but JWS is allowing scientists to observe the mechanisms of the universe. By doing so, we are now aware of the universe's trajectory. Instead of accelerating the expansion, the universe has stopped expanding, and hence with time, this curve or the sphere that holds our universe would gradually collapse. This theory isn't new to scientists, but it's only with the James Webb Space Telescope that we have the evidence to confirm it. Imagine it as a full circle. Our universe has reached its peak of expansion, and soon enough it would start collapsing on itself. This collapse is the end of the universe as we know it. The James Webb Space Telescope is an amazing creation that is paving the way for how we understand the universe. The latest images from the telescope reveal that light is bending at the edges, which means our universe has stopped expanding. And it also means that we're closer to our ultimate end than we thought. Whether this is going to happen in the next few centuries or a few thousand years is anyone's guess. But for now, our knowledge of the universe has reached an unfathomable stage, which, by the way, is pretty terrifying. The revelations from the James Webb Space Telescope, JWST, have stirred the foundations of our understanding of the universe, particularly concerning its expansion and ultimate fate. For decades, the prevailing view was that the universe, born from the Big Bang nearly 13.8 billion years ago, has been continuously expanding. This expansion, theorized as the aftermath of an explosive beginning where space itself rapidly stretched and carried matter along, seemed to suggest an infinite trajectory. However, the JWST has now provided data that challenges this long-held belief. Instead of observing an accelerating expansion as previously thought, the telescope's precise measurements of light bending through spacetime have indicated that the universe's expansion has slowed down significantly, possibly to the point of stopping altogether. This discovery has profound implications for cosmology and our understanding of the universe's eventual fate. One of the key aspects illuminated by JWST's observations is the nature of space itself. Rather than space expanding uniformly in all directions, the telescope's data suggests that the universe may be more curved or closed than previously assumed. This curvature indicates a potential spherical or closed geometry, where space wraps around itself in a finite manner. Such a revelation challenges the linear model of infinite expansion and prompts scientists to reconsider the ultimate fate of our cosmos. If the universe has indeed ceased expanding and is instead curved, as JWST's findings suggest, it opens up the possibility of scenarios previously relegated to theoretical speculation. One such scenario is the concept of a big crunch, where the universe, instead of expanding indefinitely, reaches a maximum size and begins to contract under the force of gravity. This contraction would eventually lead to a collapse, resulting in a cataclysmic event akin to a reverse Big Bang, where all matter and energy converge into a singular point. The prospect of a big crunch raises intriguing questions about the cyclic nature of the universe, positing that after such a collapse, a new cycle of expansion and contraction could potentially begin anew. This cyclical model, while speculative, offers a tantalizing framework for understanding the universe's past, present, and future, suggesting that our cosmos may have undergone multiple iterations of birth, expansion, contraction, and rebirth throughout its unfathomable history. Moreover, JWST's observations provide valuable insights into the nature of dark energy and dark matter, two enigmatic components that collectively constitute the vast majority of the universe's mass-energy content. These entities, whose existence is inferred from their gravitational effects on visible matter and light, play crucial roles in shaping the large-scale structure and dynamics of the cosmos. Dark energy, believed to be responsible for the accelerated expansion observed in the early universe, may now be reconsidered in light of JWST's findings. If the universe's expansion has indeed halted, the role and properties of dark energy may need to be re-evaluated to account for this unexpected development. Similarly, dark matter, which interacts gravitationally with visible matter and helps in the formation of galaxies and galactic clusters, continues to intrigue scientists as they seek to unravel its fundamental nature. Beyond its implications for theoretical cosmology, JWST's groundbreaking discoveries have practical applications for future space missions and astronomical observations. The telescope's advanced capabilities in capturing infrared light from distant celestial objects allow scientists to peer deeper into space and time than ever before, revealing previously unseen phenomena and expanding our knowledge of the universe's early epochs. For instance, JWST's observations of distant galaxies and protostars provide invaluable data on the processes of star formation, galaxy evolution, and the conditions prevailing in the early universe. By studying these distant cosmic entities, astronomers can test and refine existing theories of cosmological evolution and gain insights into the fundamental physics governing the cosmos.